James Webb Space Telescope spies a strange shape or shapes above Jupiter's Great Red Spot. This is a NASA image by ESA, Webb, NASA. Now, astronomers using the James Webb Space Telescope, JWST, have spotted a previously unseen structure. It's a structure in the atmosphere above Jupiter's famous Great Red Spot. Using the James Webb Space Telescope, astronomers found previously unseen structures and activity in Jupiter's atmosphere above the Great Red Spot. These odd features seem to be caused by powerful atmospheric gravity waves. The Great Red Spot is the largest storm in the solar system, twice as big as Earth, and is believed to have been ranging for at least 300 years, according to NASA. The winds of the Great Red Spot range at around 270 to 425 miles an hour, up to 3.5 times as fast as a tornado here on Earth. And yet, despite the storm's age, size, and power, scientists had actually suspected that the atmosphere of Jupiter above the Great Red Spot was not all that interesting. However, these new observations delivered by James Webb Space Telescope Near Infrared Spectrograph, NIR SPEC, instrument, which observed the massive scarlet storm July 2022, show that this assumption could not have been more wrong. Now, we thought this region, perhaps naively, would be really boring. Team leader Henrik Melin of University of Leicester said in a statement, "It is in fact just as interesting as the Northern Lights, if not more so. Jupiter never ceases to surprise." What secrets has the Great Red Spot been hiding? Jupiter's upper atmosphere is the point at which the planet's lower atmosphere meets its magnetic field. This leads to bright northern and southern lights powered by bombardment by charged particles from the sun and fueled by sprays of volcanic material erupting from the Jovian moon Io, the most active volcanic body in the solar system. Jupiter may be one of the brightest objects in the night sky over Earth, easily seen in clear skies, yet apart from its northern and southern lights, the atmosphere of the solar system's largest planet only glows weakly, making it difficult for ground-based telescopes to see in detail through Earth's atmosphere. From James Webb Space Telescope's position 1 million miles away from our Earth, our planet's atmosphere is no hindrance to the $10 billion Space Telescope. In addition to this, the James Webb Space Telescope's sensitivity in the infrared spectrum allows it to see the gas giant's atmosphere in intricate detail, including the region over the Great Red Spot. Aiming to discover if this region is a bit dull, Melin and colleagues targeted with NIR SPEC, the main instrument of James Webb Telescope, and this led to the discovery of a variety of intricate structures across the field of view, including dark arcs and bright spots. Though incident sunlight is responsible for the majority of the light seen from Jupiter's atmosphere, the team thinks that there must be another that is giving rise to changes in the shape and structure of the upper Jovian atmosphere. One way in which you can change this structure is by gravity waves, similar to waves crashing on a beach, creating ripples in the sand, Melin explains. These waves are generated deep in the turbulent lower atmospheres and are all around the Great Red Spot, and they can travel up in altitude, changing the structure and emissions of the great atmosphere, the upper atmosphere. These gravity waves are very different from gravitational waves, the latter of which are tiny ripples in space and time predicted by Albert Einstein in his 1915 theory of general relativity. Gravity waves propagate through the atmosphere as opposed to the fabric of space-time as gravitational waves do. These atmospheric gravity waves are also seen on Earth occasionally, but these earthbound waves are much less intense and powerful than the same phenomena occurring over Jupiter. The team now hopes to follow up on the detection of these newly found Great Red Spot features in the intricate wave patterns underlying them with the James Webb Telescope This future investigative investigation could reveal how the waves flow through the gas giant's upper atmosphere and how this causes the observed structure to move. The findings are expected to help better understand the distribution of energy across Jupiter and could help support the European Space Agency ESA mission Jupiter Icy Moons Explorer JUICE. JUICE launches April 14, it launched April 14, 2023, and is expected to reach Jupiter and its moons in the year 2031, when it makes detailed observations of Jupiter and its three large ocean moons, Ganymede, Callisto, and Europa. The results were published in the journal Nature magazine. This was originally from space.com, and it's on Live Science by Robert Lee. Please leave your comments, and thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.